Hello, today we're going to talk about the properties of buffers. So buffer solutions can have two different forms. It could be a weak acid with its conjugate base, or it could be a weak base with its conjugate acid. But it must be a weak acid or a weak base. It cannot be a strong acid or strong base. It must have its conjugate present as well in the solution. So an example would be putting NH3 and NH4 plus in a solution together. What makes this a buffer is that it has two components, and both of them are going to be useful in keeping the pH constant. So if you have NH3 as a weak base, if you were to add in an acid into that solution of your buffer, the acid would react with the ammonia part, and it would form NH4 plus. So it would neutralize that excess acid, as long as you had NH3 present. If you were to take that same buffer solution and instead add in a base, it would react with the ammonium, and it would form ammonia with water. So buffers are really, really cool because they have both parts of a conjugate pair, an acid and a base present, and they can both neutralize acid or base when they're added in to keep the pH constant. So there's some different ways that you can actually make a buffer solution. You could actually put the weak acid in a solution with its conjugate base. And be careful, the conjugate base could be written as a salt. So if you have something like HNO2 is a weak acid, it could be put with something like KNO2. But alkali metals are soluble, right? Group 1 metals are soluble. So really, that KNO2 is the same thing as saying NO2 minus. So you have your weak acid and your conjugate base. You could also just take a weak base and add its conjugate acid in the solution, something like NH3, and you can use a salt of the conjugate acid, so you could put in something like NH4Cl. But ammoniums are soluble, so the NH4Cl really winds up being the NH4 plus ions. So you have your conjugate acid and your weak base. But you could also form a buffer solution by reacting a weak acid with a strong base. Weak acid with a strong base. So if I use that HNO2 example and react it with something like sodium hydroxide, that's going to form sodium nitrite, and water. And it will make a buffer solution as long as you have more moles of the weak acid. You don't want to completely use up the weak acid because then it wouldn't be a buffer anymore. But if you have less of the strong base in terms of moles and more of the weak acid, then you will form some of the conjugate base. So you'll have both the weak acid and the conjugate base in the solution. Same is true for a weak base. If you have a weak base plus a strong acid, like NH3, and a strong acid like HCl, you can form that NH4 and some chloride ions. So you'll have your weak base and your conjugate acid. You just have to make sure that you have more of the weak base and less of the strong acid. Otherwise, you would completely use up the weak base and you wouldn't have a buffer anymore. So those are some different ways that you can make a buffer, and they like to ask you, especially in the multiple choice, they like to ask you about like which of the following combinations will make a buffer. And so you'll have to distinguish between them, but it must be weak acids with their conjugates. It cannot be strong. So here's an example. A buffer system composed of H2S and NaHS was created by dissolving 3 moles of each into 1 liter of solution, and draw an image to represent the buffer system. So I have 3 moles. I'm going to draw the H2S first, 3 moles of that, and I have the NaHS, it's group 1 metal, soluble. So I'm going to wind up with 3 of the sodium ions and 3 of the HS negative ions. Okay, so those ones are separate from each other. Now it says, write the reaction that would take place if a strong acid were added to the system. A strong acid, H3O plus, is added to the system. It's going to react with the part of the buffer system that is the base, so it will be the HS negative. And it would form water and H2S. Now it says to write the reaction that would take place if a strong base were added to the system. If a strong base was added, it's going to react with the part of the buffer solution that is an acid, which is the H2S, to form water and HS negative. So in both of these scenarios, when you're adding a strong acid or a strong base, it's neutralizing that acid or base that's being added to keep the pH constant.